Today we will be completing lesson 2 in booklet 12. This lesson is one-step equations using opposite operations. So in this lesson, we will be solving problems similar to lesson 1, but we're going to be using a different strategy. Instead of solving for the variable using mental math, we're going to use algebra to get the same answer. Now, even if you are able to solve it using mental math, I want you to practice with the algebra, because once these problems start getting harder, and they will in the next lesson, it will be much harder just to solve them in your head. So you need these new strategies. Now, what you need to know going in is opposite operations, right? And I will explain more in a second, but for now, all that you need to understand is that the opposite of addition is subtraction, and the opposite of multiplication is division. Okay? So, addition and subtraction are opposites, and multiplication and division are all what we call opposite operations. How are you going to use those, though? Well, let's take a look at example 1. The first thing that you need to ask yourself is, what is happening to my variable? Okay? And what's happening is I am adding 4 to it. Now, you are going to do the opposite of what's happening to the variable on both sides of the equation. One of the rules of algebra, is that you can do whatever you want to the left-hand side as long as you do the exact same thing to the right-hand side. So what I'm going to do is rewrite this problem: x plus 4 equals 6. But on the left-hand side, I am going to subtract 4. And on the right-hand side, I'm also going to subtract 4. I did the same thing to both sides. That's allowed. Now, why did I decide to subtract 4? I could have picked anything. I could have subtracted 10 or added 20 or divided by 3. I could have picked anything, but I picked subtract both sides by 4. And that's because I'm doing the opposite of what's happening to my variable. Since I'm adding 4 to my variable, the opposite is to subtract 4. Now let's take a look at what happens. Plus 4 minus 4, that equals 0. So in a sense, you can visualize them as canceling each other out. And when they do so, and this is the whole point of it, when they do so, you're left with just an x on the left-hand side. We call that isolating for x. To isolate means to be left alone, and we're leaving x by itself. We're leaving x alone on the left-hand side. So we isolated for x. Now the right-hand side, we have 6 minus 4, and that is equal to 2. So our answer is x is equal to 2. Now, you probably could have gotten this answer a lot faster if you just used mental math and visualized the answer from the beginning statement. But again, we're practicing with these strategies so that when the questions get really complicated, you don't need to use the mental math. So, when you're done, if you would like, you don't need to do this all the time, but you can always check your answer by seeing if the left-hand side equals the right-hand side. So we're going to take x equals 2, and we're going to plug that into our original equation. So we get 2 plus 4 is equal to 6, and 2 plus 4 is 6, so we get 6 equals 6. Right? So, yep, this means that we're correct. Left-hand side equals right-hand side. X equals 2 is the answer. Okay, let's try a couple more. So our next example is 2y equals 10, and we're trying to isolate for y. We want y to be by itself. So what we're going to do is get rid of the 2. Sorry, my laptop's having a moment. We're back. My apologies. As I was saying, we are isolating for y. So this 2, it's a problem. We need to get rid of it. And we are going to do so using opposite operations. So the first thing that you need to ask yourself is, what is the operation that is connecting 2 to my variable y? Now remember that when a number is next to a variable, that is implied multiplication. So there's multiplication happening there. So we need to do the opposite. The opposite of multiplication is division. So we are going to divide the left-hand side by 2. Now remember, whatever you do to the left-hand side of the equal sign, you also have to do to the right-hand side. So we're going to divide this 10 by 2 as well. Now, since we used opposite operations correctly, we can say that 2 divided by 2, that's going to equal 1, right? So this is kind of like we're left with 1y. And when the coefficient is 1, you don't need to write that at all. So the left-hand side has just become y equals. You've correctly isolated for y. Now, if you want, you can visualize that as our 2's canceling out. Now, on the right-hand side, we have 10 divided by 2. And 10 divided by 2 is equal to 5. So our answer is that y must be equal to 5. And again, if you would like to check your work, you can by substituting in 5 for y. So 2y is equal to 10. Let's take 5, plug it in for y. And 2 times 5 is 10, so we get 10 equals 10. Okay, therefore, the left side is equal to the right side. We're correct. Good. Let's try the last example. B divided by 5 is equal to 3. We want to solve for B. We want to isolate for B. So this 5 right here, that's in the way. And we need to use opposite operations. So we ask ourselves, how is the 5 connected to the variable? Well, the 5 is connected through division. Okay, so you need to use the opposite operation. The opposite of division is multiplication. So the opposite of dividing by 5 is multiplying by 5. So what we're going to do is we're going to multiply the left-hand side by 5, but we're also going to multiply the right-hand side by 5. Whatever you do to the left, you have to do to the right. Now, this will work out the same way that all of our other questions have worked out. Now, 5 times b over 5. I'm really going to draw this out the first time that I do it. When I multiply a whole number by a fraction, I imagine that that whole number is a fraction. I put it over 1. We learned this a couple of booklets ago. So it's kind of like 5 over 1 times b over 5. And when you multiply two fractions together, you multiply their numerators. 5 times b, 5b. And 1 times 5 is just 5. In other words, I can just take that 5 and put it in the numerator like this. Now, on top of that, now you might be able to see that I can divide these two 5's. And 5 divided by 5 is 1. So it's kind of like the two 5s cancel each other out. And I am just left with b on the left-hand side. Because you don't need to write the coefficient of 1. So you don't need to write all of this. You just need to understand that this 5 and this 5 are going to reduce. They're going to cancel each other out. And that's going to leave you with just a b on the left-hand side. You have isolated for b. Now on the right-hand side, we have 3 times 5, which is equal to 15. So b must be equal to 15. Again, if you would like, you can check your work. So we have b divided by 5 is equal to 3. Now what happens if b is equal to 15? That's 15 divided by 5 is equal to 3, or 3 is equal to 3. So left side equals right side. Okay, hopefully that makes sense. We will be building directly off of this for the next lesson, so get some practice for the worksheet, and then we will see you in lesson 3.